You know what that means, guys? Big Dog has a cold. Hey, but no matter what, guys, we're here working on some mathematics, so I'm all fired up even though I have a cold. Get it fired up with a cold. Makes sense. Here we go. Today we're going to talk about functions as rules and tables. So this is going to get into a little bit more complicated type stuff, a little more conceptual type math and understanding relationships between two things. There's going to be a little bit more terminology in this lesson, so make sure as we come up with vocabulary words you pause and write things down and ask plenty of questions in this lesson, please. Here we go. Let's get right into it. So, pause the video right now. I want you to write down these two definitions for domain and range. So, pause the video. All right. Hopefully you paused it and wrote down these definitions. So, first of all, we're kind of looking at these two important terms of domain and a range. So a domain is defined as a set containing all inputs, or x values, or independent variables. This has to deal with what's called a function or a relationship. What we're going to be looking at is how one thing is related to another. Now, what I like to think of domain is as all the inputs, and the range is as all the outputs. And here's how I like to think of what's called a function. Well, again, we'll look at a function just in a second. Think of a function as a machine. Function represents how something works. So I'll put here an F for function. Okay, so think of domain and range as inputs and outputs. And think of a machine. A function is machine. So what you do is you plug things into the machine. I'll label that with an I. That's my input or my domain. And when I plug it into the machine is going to spit out my outputs, which is going to be considered the range. Okay, so domain is all the inputs, the things you put into the machine. The range is all the outputs. Okay, now in a table or anything I would give you, the domain represents all the x values, and the range simply means all the y values. In any sort of function, we plug in things to x, and what we get out is y. All right, so there's some general terms in domain and range. So if I were to look at this table, I give you input in gallons. So 10, 12, 13, 17, and then output in dollars. So imagine you're putting gallons of, let's say, gasoline into your tank of your car, and you have to pay based on the amount of gallons you put in. All right, so the domain is all my inputs, or all the x values. So you can see here in this table, this is the input. So this is going to be my domain in this first column, first row, second row, my output. That is going to be my range. Now, how do I label my domain and range? So the domain and range, you are going to use what's called a brace, or you can think of it as the squiggly parentheses, okay, or the squiggly brackets. All right. So I'm just basically going to list out all my inputs in order. So I have 10, 12, 13, and 17, and then I'm going to close my brackets, or my brace. All right, that's my domain. Okay, question is, do you have to use these squiggly brackets? Yes, you do. Do you have to close them at the end? Yes, you do. Why? My simple answer, because Stone Cold said so. This is just simply how we label our domain, so you have to label it that way. The range, we do the same thing. Okay, we're going to use these squiggly brackets. That's kind of sloppy right there, but now I'm going to list all my outputs. So I have 1999. I have 23.99, I have 25.99, and lastly 33.98, and then I'm going to close. Okay, so just by listing out all the inputs and listing out all the outputs, that is what's considered my domain and range. All right, next term, this is kind of the meat and potatoes, a function. I kind of mentioned this already. What is a function? Well, if you think of a function or the word function, function means how something works. If I were to ask you, how does a quarter machine function? I'm basically asking you, how does it work? Okay, so how does it work? Think of a quarter machine. You take an input, you plug it into the machine, and what does the machine do? Gives you some output. My function represents the machine. Think of a quarter machine. Okay, if I plug in a fresh, crisp, $1 bone, what do I get out? A nice, shiny, new quarter. In fact, I get, hey, 4 of them, right? So I plug something in, I get something out. Input, output. That's what a function is. Now, the main rule that we're going to follow for a function, here's what I want you to pay attention to. Hopefully I forgot to say it to pause and write down this definition. But we have the definition here of a function, which is what we're going to have to really focus on, is that in order for something to function properly, in order for an actual relationship to be a function, every input has to be paired with exactly one output, meaning every input has only one output. There can be no one input that has more than one output, and I'll try and explain that in these two examples. So take, for example, teachers in their classrooms, right? I teach in room 170, so there's my room, right? Mr. Seafeld teaches in room 181, right? And lastly, Mr. Madden teaches in the field house. Right? So, right there, what I see is that every input, the teacher represents the input, is paired with exactly one output. Okay? Now, follow along with that. I'm going to erase these lines, and here's what I want you to think about. I like the field house. Okay? I like to put in work, and that's why I put in work other than my classroom. So, not only do I want to teach in 170, but I want to teach in the field house too. That'd be pretty sweet. Now, think about what this says. All right? This says that I, Mr. Wazakowski, want to teach in room 70 and the field house at the same time. So really think about that. Is it possible for me to work in the field house and in room 170 at the same time? No. This right here, folks, is not possible. I cannot be in two places at one time. An input cannot have two outputs. It can only have one output. All right, let's take a look at the second example. Now follow me along in this one. I know this is going to sound kind of silly. Let's say that I am making a mini pizza or mini calzone. So let's say I have one pepperoni, one sausage, and only one piece of mushroom. I got one piece each. So think of this input and output, right? I have one piece of pepperoni, one piece of the sausage, and one of the mushroom. Okay, and I want to make a piece of the pepperoni. Well, if you think about this, I have one piece of pepperoni. What do I want to put there? Let's say I like pepperoni pizza. I love pepperoni pizza. Because of the pepperoni the pizza, you get a lot of the grease. And I love the grease on the pizza. It's very fantastic. Okay, so I'm going to make one pepperoni pizza, right? And let's say then I'm going to put my sausage and mushroom. I wish I had some onion right now to put on that calzone. But I have one sausage, one mushroom. Same thing goes. If I have one of each, if I have one pepperoni, one sausage, and one mushroom, now think about that. May not make sense. But if I have one of each thing, there's no possible way that I could have one piece of pepperoni and one piece of pepperoni on my pizza and one on my calzone at the same time. This is not physically possible if we just have one of them. So again, think about having one input and one output. It's impossible for that one input to have two outputs at the same exact time. And that's what we're getting here with a function. Rightio, so let's do some examples. What I have here is three things. I have what's called a mapping diagram. This is a diagram to show just how inputs and outputs are related. I have two tables here. Basically, they're going to show us inputs, outputs, and our goal is to figure out whether it's a function or not and to identify the domain and range. Okay, so the first one, I have what's called a mapping diagram. Just shows inputs to outputs. The arrows represent which input goes to what output. So looking at this, is this a function? So remember, to be a function, one input has to have one output. All right, so I have this. I have 4 goes to 0. I have 5 goes to 1 and 2. Uh-oh, Pescadios. I should see that one right there. The input of 5 goes to 1 and 2. It has 2 outputs. So this one is not a function. I'll just write no. But anyway, so because it's not a function, I'm not even going to worry about the domain and range. Since it's not a function, I'm not even going to care about that. Okay, now let's look at the next one. I have my inputs in a table and my outputs in this table. So it's going to be a little more difficult to think about. But think of my inputs, 4 to 10, 5 to 10, 6 to 10, 9 to 10. Okay, so each input is shown with its output. Now, if you think of this, I'm going to kind of draw this similar to the last example we did. Think of my inputs as 4, 5, 6, 9, and my output, notice all my outputs are 10. So if I draw like a mapping diagram, 4 goes with 10, 5 goes with 10, 6 goes with 10, 9 goes with 10. Okay, now this one's a little tricky. Is this a function? What do you think? Well, this is a function. This is a big ol' yes. Okay, this actually is a function. Why? Because every input has only one output. 4 has a one output of 10. 5 has 10, only one. 6 has only 10, and 9 has only 10. Now 10 is shared by all 4 of the inputs, but that still means all the inputs have one output. Think of a car. How can you, let's think of an output, like braking. How can you brake in a car? Some of you might not drive a car yet, but you can hit the brake pedal. That's going to cause you to stop. You also have an emergency brake. That's a different input, going to cause you to stop. You also can take the shifter and put that in the park. That's going to cause the car to stop too. The whole idea here is that you have different inputs, the brake pedal, the emergency brake, putting it in park. All those things are going to make the car have the same output of stopping. Okay? Think of a car, that functions. That's a functional machine. We use them every day. If they didn't work, why would we use them, right? So this right here, be careful. If you have one output shared by all the inputs, that's perfectly fine. This is still a function. All right, then the last thing we have to do, since it is a function, let's define our domain and range. So our domain, again, is all our inputs. So heck, the inputs are that first row. So it's my domain. I'm just going to put a D so I know it's domain, and then I'm going to put my squiggly bracket there. So what are all my inputs? I have 4, 5, 6, and 9. Those are all the things I'm inputting into the function. My range is all my outputs. Well, hey, that's 10. Notice how it's written 4 times. I have 4 different 10s. Do I need to write it 4 times? Absolutely not. My range is just that one single 10. Okay, so that's my domain and range. All right, let's take a look at this last example here. I have inputs of 10, 10, 10, 10, and my outputs of 4, 5, 6, 9. So what did I do? I took the table from before, and I flipped it. Holy cow, I flipped it. So is this a function? So again, to help you out, it might be helpful to draw this little mapping diagram where I have 10, then I go 4, 5, 6, 9. Okay, so 10 is with 4, 10 is with 5, 10 is with 6, 10 is with 9. Uh-oh, Piscadio. 10 is my input. One input should have only one output. How many outputs does this 10 have? It has 1, 2, 3, 4. So it does not have one output. Therefore, this is not a function. Okay? And I'm not even going to identify the domain and range because it's not a function. Okie dokie, artichokes. Let's do a little more difficult, get a good English, of a function. So here I have my table kind of set up. I'm telling you the domain is 2, 6, 10, and 12. But what I have here is this y equals 1/2 x plus 7. This right here is known as a rule. It is called a function rule. What a rule does is it explains the relationship between two things, x and y, two variables. We talked about variables in the last video lesson. Okay, so a variable is something that represents some number that we can then find a solution for. Okay, so what I want to know here is I want basically giving you the domain, which is, remember, what is domain? Domain represents the input. Giving you the input, I want to figure out what is the function rule. Okay, so think about this. Domain represents all of the x values. So if the domain represents all my x values and the domain represents my input, think about what we're going to do with this rule. Think about it, think about it, think about it, think about it, think about it. Well, hopefully you thought about maybe taking the inputs and plugging them in, substituting them in for the variable, kind of what we did in the last video, right? And we're going to do exactly that. To find my y, to find my outputs, I'm simply going to take my input and plug it in for x. I'm going to substitute it in. And I'm going to then evaluate this expression to figure out what y equals. So let's go ahead and do that. So the first one, when x is 2, I'm going to plug 2 in for x. I'm going to write this as 1/2 times 2 plus 7. And evaluating that, that's going to tell me what y is. Okay, so let's do this quickly. 1/2 of 2, what is that? That's 1. Add 7 to it, we get 8. Okay, so that's going to tell me that y is equal to 8. Again, using a little bit of order of operations. Next one, I have 1/2. I'm going to take now and plug in 6. 6 and then plus 7. So 1/2 of 6 plus 7. So 1/2 of 6, remember that means multiplication. 1/2 times 6 is 3 plus 7. That is going to give me 10. Order of operations again. Next one, I have 1/2 of 10 plus 7. 1/2 of 10 is 5 plus 7. Oopsie, that's bad. 5 equals 12. Okay, and then the last one, we have 1/2 of 12 plus 7. 1/2 of 12 is 6 plus 7 is going to give me 13. Okay? So, my inputs are 2, 6, 10, and 12. What I did is I plugged those inputs into my rule, into my function for x, because inputs and x are the same thing. And what I then found out was my outputs. And remember, outputs represent my y. Now, the last thing it's asking me to do is to find the range of the function. Not the derange, but the range. So remember, the range simply represents all of the y values, all the outputs. So what are my outputs? Well, we just solved for them. 8, 10, 12, and 13 represent my range. Those are all the values that are my output. Okay? So what I then did is took my ideas of domain and range and my function and now stated a rule. All right, a little more challenging problem here. Now we're going to do the opposite. I'm going to give you a completed table. I'm going to give you a completed domain and range, input, output, and I want you to write a rule. So a rule, think about what we did in the last example. We had the y equals 1/2 x plus 7. Notice that the input, think of that, we plug the input in, we get an output. The machine takes the input and figures out what the output's going to be. So all the stuff we do mathematically is going to be done to the input, to the x value. So what I want to figure out is what is being done to my input to get my output. So what we have to try and do is find a pattern. So let's take a look at this table. My inputs are on the first column. So let's look at my first one. I have 4, and my output's 8, meaning I plug in 4, I get 8 as a result. So how the heck do I get from 4 to 8? So what are some options we have? Well, you may say, okay, you multiplied it by 2. You doubled it, right? Okay, in order for this pattern to be true, in order for this to be a rule, it's got to be consistent with all the other inputs and outputs. So let's check the next one. If I multiply 7 by 2, do I get 11? Oh, no, you don't, right? This is not true. So right away, I know that's not the rule. So what else could be a rule? Well, 4 to 8. Let's go back and look at this. Instead of multiplying by 2, maybe I add 4. 7 to 11. Add 4, is that true? Oh, yeah. 10 plus 4, does that give me 14? Cha-betcha. 13 plus 4, does that give me 17? Yes, sir, or ma'am, right? So I know that what I'm doing is taking my input and I'm adding 4 to it to get my output. Okay? So I'm going to take my input, I'm going to add 4, and that is going to give me my output. And that's my rule. Now when we write this, instead of input and output, I'm going to take x as my input, I'm going to add 4 to it, and that's going to equal y. Now does it matter that I wrote y over here and over there before? No, it does not. Okay? For right here, that represents my rule. That explains what's going on in this table. Okay, the fun thing about these problems is you have to figure out the pattern. That's what gets a little challenging. So for some of you, this is going to be a lot of fun. All right, so I want you right now to pause the video. Pause the video. I want you to try these two problems. First one, tell whether the pairing is a function and identify the domain and range. The second one, just like the problem we just did, find a rule given that table of inputs and outputs. All right, so pause the video. Go ahead, try these. Ready, set, go, 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 go. Okie dokie dokie okie, here we go. Let's take a look. So first one, whether it's a function. So what I saw, inputs, 1 to 3, 0 to 5, 6 to 3. So does each input have only one output? Okay, and the answer is yes. Or C, for those of you that speak German. All right, so this one, You may get confused with the 6 and the 1 both going to 3. But remember my car analogy. 2 inputs can have the same output. You can have your brake pedal and your emergency brake both stop the car, right? Same thing here. 1 and 6 can both have an output of 3. That's perfectly fine. As long as one output or one input does not have 2 outputs. That makes sense. Okay? Now, domain and range. Domain is all the inputs. So I have here 1, 0, and 6. Had my sassy brackets. And now notice how I did this 0, 1, and 6. I put them in numerical order. My range. Squiggly brackets. I have 3 and 5. So boom, 3 and 5. So that's my domain and range. All my inputs and all my outputs. All right, number 2, hopefully you got this right away. Find a rule for the following function. So again, we're going to see what happens to the input to get us our outputs. So you should have noticed right away, the only way to get from 3 to 0, other than multiplying by 0, would be to subtract 3. So if you check that rule in every case, it ends up working out. So subtract 3 in every single one works out, so that I know that I'm taking my inputs and subtracting by 3 to get my outputs. So my rule would be y equals x minus 3. All right, so again, if you had any questions, make sure you write those down in your notes, and we'll see you in class next time. Hopefully by next class I'm feeling a little better, and you guys are feeling great and ready for math. Adios, muchachos and muchachas. We'll see ya.